This subject's all about virtualization with Hyper-V, and it's got. So let's look at the subject to units. It's got these two competencies. Okay, so it's associated with these two competencies, and obviously for some of you guys who've been transitioning, you should be registered in both. For some of you guys who don't need both, you could be just registered in one. And obviously, have a look at your study plan. Have a look at the CRNs that you've been given, because obviously, if you're doing this subject and you can get both, that's a bit of an advantage for you. If you have any interest in actually what the competencies say, these are a couple of links to have a look at what's in the competencies. Just it's not very interesting reading, to be honest, but we do assess according to what's in the competencies, unfortunately. So even though some things are boring, it's actually part of the assessment. Moving on, so you guys should be familiar with how TAFE subjects work now at this stage, but we do have a study schedule. Okay, for us, for example, it's this one. For you, Matthew, it's this one, because you're an external student. But to be honest, it's not much difference between the two, because since we switched to a semester delivery instead of a term delivery for the in-class or in the virtual class. So if you look at this, nothing dramatically new that you were aware of. Basically, the topics and when we're covering it, and probably just as important, when assessments are due. Okay, so the general rule with TAFE, with TAFE is that you get 2 attempts with every assessment, but the general rule is that on the due day of the assessment is your first attempt. Meaning, if you don't hand it up on the due date or before the due date, if you hand it up after the due date, it will be counted as your second attempt. So just be aware of that, because obviously TAFE is not meant to be super hard to pass. It's relatively straightforward. The general rule is you attend classes, listen, pay attention, understand what the lecturer is saying. If you don't understand, ask questions, do the activities, and do the assessments. And the thing about assessments is, if you do an assessment, give it a good try, and even if you got 80% completed and you hand that 80% completed up, your lecturer is able to then give you feedback on what you've done to tell you if you've done it correctly or if something is incorrect and needs to be improved. The problem is, if you don't submit anything, the only feedback you're going to get is that you haven't done it. Okay, so generally, if you make a good attempt, the lecturer will explain what's missing, what you didn't address, if you need to fix it. If you did do a good job, then you know you did a good job, and then you can just look at the parts that you didn't necessarily meet the requirements, and that way you can put those fixes into the second attempt. So try to take advantage of that. You guys are all smart. Don't be silly. Use your attempts wisely. All right, so now we're talking about resources. Okay, so this is a virtualization subject. So basically, we have a great demand on the hardware. Okay, so we're going to at times have up to 6 or more VMs running at the same time. Okay, for those of you who did the 4SCCM subject, this one is not as demanding as that subject, but this is still up there. Probably one of the top 3 or top 2 subjects that needs hardware resources. So it says minimum 16 gigs of RAM, minimum 120 gigs of solid-state hard drive. That's the minimum. Okay, so obviously, if you want things to run even better, especially now with people are easily getting more than 16 gigs of RAM and easily more than 120 gigs of solid-state hard drive, and also a lot of students even have the NVMe solid-state hard drives and high-performing solid-state hard drives, then that's going to just make your life a lot easier. The more memory you give to your virtual machines, the better they're going to run. The faster you have solid-state hard drives, the better they're going to run. I think we're all familiar with that idea. Unfortunately, if you don't have those system requirements, then it's going to be very difficult for you to do some parts of this subject. So beg, borrow, or don't steal, beg, borrow, or get access to a computer that does have those requirements. I think from just a quick poll, uh, just a quick poll. Does your system meet the requirements, as in 16 gigs of RAM, solid state hard drive with probably at least 120 gigs free? Okay, so let's have a look at the results. Yep, looks like everyone's good, so no need to worry here. No problems. Easy. All right, good. So let's move on to the next part. The next part is probably the most important thing for a student. What do you have to do to pass this subject? All right, so it's fairly straightforward in the sense that there's not many bits and pieces, as in little bits and pieces of assessment, but there is two. Okay, there's two. There's a practical assignment. It's pretty straightforward. It's probably the easier one of the two in this subject. You build a structure, okay, with Hyper-V, a domain, storage, network, live migration network, etc., as the requirements are written here. Similar to the for AWS or for IMWS you would have all done, it's based on a checklist, meaning that as you're doing it, I will check things off. Yeah, general rule with these kind of checklists is don't wait to the end to get everything checked off, because just imagine me as a lecturer checking off all of your work from start to finish, all on the last lesson. Probably not a great lesson for me or for you. The worst thing is if you make a mistake or if you haven't done something absolutely as required, then you'll be told this is not quite right. This is why it's not quite right, and then you get to fix it. If it's all on the last day, you're not going to get the chance to fix it. It has to be right. So basically, with this, there's not like it's two attempts, like I suggested before. It's more like you do it and do it and do it until you get it right or up to the time limit, which is what it says in the schedule. Okay, like a bit like more like a real life project. You have a real life project. It's for this. The scope is this, and these are the requirements, and this is the project length. And obviously, if you deliver the outcomes for the project within that time, within the budget, it's a successful project. It's more based like that. So that is the more straightforward one of the two, and the second one is the probably harder one. It's a written assessment. It's a migration assignment. So the scenario is you've got some old virtualization with some free ESXi, vSphere, but you want to transfer over to the Microsoft Hyper-V, okay? And you're doing a side-by-side comparison and some other things in there. So we're not going to worry too much about these assignments just yet, because right now I don't think off the bat, unless you've already have some knowledge in Hyper-V already, you'll be able to do any of the assignments just yet. Okay, so not to say that we won't be able to do it in the short next couple of weeks. Okay, so I think we shall start. If we look at this it's not written there, but I would recommend that we start your assignment probably after lesson 3. Okay, at that stage you should be able to build the basis at least. Okay, build the base, and that way you can obviously during those lessons we'll be learning how to do some of these things. Okay, so that's what's required to pass the subject. So just keep that in mind, keep an eye on the due dates, and obviously in class when we're finished with the theory element, you'll get me to check it off. And in this case, it's going to be through the Collaborate, or where I'll make you a presenter and you'll share your screen. Any questions at this point, guys? Any questions? Nope. Good. That's good. No worries. All good. No worries. Let's get into the topic then. Okay. So, oh, sorry. One more word is that we need access to some base virtual machines. Okay. Yeah, the VMs. The good point. And uh, VMs, they're usually on the L drive. So they're pretty big. If you can get to a TAFE campus, and they have a IT hub at every campus, and you'll be able to access the computers there, bring your portable hard drive, copy it from the L drive, IT Studies NAS. But if you're stuck at home or you're in a regional area, which I don't think any of you guys are, don't forget there's instructions. You can just build them yourself as well. You definitely can. Nothing to stop you doing that, but obviously you guys should all be aware that you can access the IT Studies NAS at home. Not to say that it's going to be working too great, but it's possible. Okay, so if you are stuck in a regional area, you can't get to a campus, yeah, it's very slow. You can log in with your TAFE credentials. You notice that it's formatted differently. It's TAFE SA, which is the domain, backslash, your username, which is the normal one you use for logging onto a computer, and then your password. And once you get in, you should see that the files are just like what you see on the L Drive IT Studies NAS. Basically, it's the same computer. And if we go to VMs, I think we have 5.0 ISV 2016 VMs, and you can see there's a golden master. We should be all familiar with the idea of the golden master being the template virtual machine. We've got a domain controller. We've got the Hyper-V 1 and 2. We've got the SAN storage area network, and we've got the VMM. Okay, so to be honest, the VMM won't be needed until the second half of the subject, but you'll need everything else beforehand. There's some utilities, there's some scripts, there's all that kind of stuff. And you raise your hand. What's your question?
Hey, Alex. Just basing with those VMs, because I obtained them from my campus the other day. There was a bit of a skill glitch I had with VMware, that it was showing up all the virtual networks as host only. So I'm not sure, is that a configuration issue with the VMs, or is that something on my end that's causing that issue?
I can't remember off the top of my head if they're host only. They should be mostly host only. I think there's going to be yeah, I think they are actually host only, but they might be different host only for the SAN networks.
Okay.
Yeah.
Because I was just wondering, did they have to be put on separate VM nets instead?
Well, let's have a look at the worksheets. That's probably the best way to tell.
I did have a look at them, and it wasn't very clear to me, I'm afraid. So hence why I'm asking the question now.
No worries. And let's have a look at them together. Oops, that's the wrong thing. So lab 2 is really the build.
Yeah, so that's the one where I got up to, and then I just got stuck because I was like, shouldn't they be on different VMware nets or something like that? Because I think host only, doesn't it only use the one network address on it?
Okay,
in
so
VMware?
You got to understand that IP address is only for giving out IP addresses for your virtual network, right? So unless you use the DHCP service, it really doesn't matter what you allocate.
Okay, yeah, gotcha.
Yeah. So by looks of it, the corp is all one network. The SAN two network. There's a live migration network, IP cluster network, and then the gateway, etc., etc. Okay, let me see if I got a copy on my local machine to see if I can open it up for you. But to be honest, I think there's meant to be on the host only network. They might be just different host only networks. Okay, it doesn't look like I do have the virtual machines on my computer at this second. Eve, I remember, I know you know. Are you there, Eve?
Sorry, I'm here.
Yeah, so do you remember if the virtual machines are all on the host only network?
So I can't remember the labs, but I know for the assignment, there are 2 host-only networks and 1 NAT, which NAT's your live migration.
No, I think that's for the WSUS. That's okay. Yeah, so Matthew, to answer your question, it doesn't matter if they're all host only, okay? Matthew, you there?
Sorry, just experienced a couple of technical difficulties. That's all clarified. Thanks.
All right, no worries. So basically, it doesn't matter that they're on host only, and that's fine, because to be honest, all those ones, they might be different host only networks, but it doesn't matter if they're host only. Let's go into the topic. Okay, so today we're looking at evaluating the environment. All right, so this is based on a Microsoft course. It was based on the 2012, but obviously the information in here is still applicable to 2016, which is what we're talking about. All right, so today's module 1, evaluating the virtualization environment for virtualization. Okay, so today we're going to give you a view of Microsoft virtualization, some of the system center components, evaluating the current environment for virtualization, and extending to the cloud. But really, in this subject, we're not going to extend to the cloud, which is the Microsoft Azure Cloud. We talk of the possibility that we can. If you guys are doing the 5 PTS subject, produce technical solution, that will include Microsoft Azure as the next step. Okay, so that subject really follows on from this subject. So let's go have a look at some of these topics. So it's traditional challenges. So when we're talking about traditional challenges, we're talking about challenges with the traditional network service. Okay, so when we talk about traditional network servers, we mean physical servers. So basically, every server is a physical machine. So some of the problems is that the space. Okay, if you need 10 actual servers, Active Directory, DHCP, file server, web server, this and that server, whatever, then you end up with 10 physical machines. So some problems is the housing of this equipment. So obviously that means you probably need room for 10 physical machines because of those 10 servers. What about power? Power means that each server needs to be powered, and each one draws power, regardless of how much utilization they're getting. They're drawing power. So providing affordable power to run the servers, storage, and network equipment. So obviously, if you have 10 physical servers, you would need 10 of everything that is required by the servers, including cables, ports on the switches, UPS, etc., etc. And what about cooling? Okay, so we've got 10 servers, and each server will produce heat, as we all know. And obviously, the more heat it produces, the more we have to cool, more money we spend towards the cooling, maintaining a safe operating temperature for the equipment. Resilience, that's a big one. Resilience. If you had a physical server and something went wrong, let's say the motherboard broke, it just exploded, the big cracks, and it just stopped working. Okay, probably not a realistic situation there, but just say it did. Okay, what could you do with that server? Let me ask you that. If you had a physical machine and the motherboard just cracked and it broke and doesn't work anymore, what could you do? Guys, I know this is a virtual classroom. If it was a real classroom, I'll be looking in your eyes and picking you out. So if you had a physical machine and the motherboard broke, what would you do? Replace the motherboard. Yeah, what if you can't get the exact same model because it's 5 years old? Solder it. If you can, I guess that's always risky. Go out, buy a new server, new motherboard, upgrade to a new physical server or a new motherboard, right? Yeah, but go to the cloud. Well, yeah, that's not traditional, is it, Eve? So So basically, you guys are right. So if we did have a problem like that, and obviously your servers are not going to be brand new for the rest of their lives, so if they were 5 years old, it'd be probably a little bit hard to source the same exact motherboard again. And obviously, either way, it doesn't matter if you can source it or you can't. But basically, your server is going to be offline until you get it. You get that piece of hardware, whether that's a brand new piece of hardware, a replacement motherboard or upgraded motherboard, it's going to be offline until you get it in and replace it, isn't it? So that's a big problem. So building a robust and highly available solution and offer a means to recover the data. So that's always a big challenge. That's one example. What about flexibility? Providing the time to deliver or upgrade infrastructure or applications. Let's say you want to actually change to Server 2019. You're not 100% sure everything's going to work properly. Let's say you got this proprietary app that's running on your Server 2016, and you want to switch to 2019. If you didn't have virtualization or the cloud, because we're talking about traditional, how would you do that? Again, how would you guys do that? If you want to test out 2019 in a traditional LAN, how would you check that compatibility? Downtime, yeah, the result is downtime. Well, you don't have virtual machines, Zach, so we're talking about the traditional one. Okay, so obviously for us, we know VMs are good, but we're talking about the traditional one. Yeah, it's going to be, the result is offline. So basically what you have to do is go get a piece of hardware, install Server 2019 on it, then put the app on it, and then test it. So time it takes to get that piece of hardware, time to install the operating system and update it to the latest patch, time to put the app on there, and then testing. A lot of time, isn't it? Well, obviously we all know with VMs, if I want to test something, I just spin up a new VM. If I have to, I'll install the operating systems from scratch, but I've just got a clone. I can clone it from a Server 2019 that I've created for some other reason, the app on and test it. So a lot less time, so a lot more agile, as they call it. So we could test something out, get something, a solution or a sort of a working prototype up and running within minutes. Unlike double way, which is actually looking at days. Resources, maintaining staff to system ratios and meeting training challenges. So that's traditional challenges. So what is virtualization? We all know that. Server virtualization you can create multiple computer operating systems on a single physical computer. We're not talking about dual booting or multi-booting. Okay, we're talking about many operating systems running at the exact same time and being isolated from each other, running on the same physical computer. Host servers share resources. We're all virtual machines. We're very aware of that because of the demand on our physical machines, such as the hard drive, where we need SSD and the amount of memory, network bandwidth, and CPU time. Some virtualization challenges, so limited number of compute resources. So basically your resources, your limit. Okay, yeah, obviously there's abilities to fix that, is to actually introduce more and more virtualization hosts, but obviously how many virtual machines you run is limited by your physical resources. Server virtualization features, so Hyper-V server virtualization feature allows full utilization of physical resources and provide a advanced technology to make a more robust, available dynamic server computing environment. That sounds like a lot of marketing there. Let's just put it this way. Each and every one of you, look at your computer right now. Okay? So my computer right now, if I press Control-Shift-Escape and I click on performance, you've all done this before. So my computer, what am I doing on my computer? I've got a couple of documents open. I've got it. Yeah, you're very special, Matthew. Thank you. No words, because I don't assume people use Macs in networking. Um, uh, so with that, what I'm trying to illustrate is if you look at your own computer, what am I doing? I'm actually doing my job. Okay, I'm doing my job. I've got the PowerPoints open, as you can see. I've got documents open. I've got browsers, many tabs open. I've got Microsoft Teams. I've got the email, and we've got the Skype for Business and Internet Explorer for some reason, and and uh, many other things. If you look one of this, I've got a whole heap of stuff running. Okay, so I would say this is my normal day to day. Okay, usage of computer. But you can see right now, even though I'm using this computer, normally, probably more so than normal because I'm actually doing a live, collaborate class with you guys. You can see that I'm only utilizing 30% of the CPU. If I'm looking at my memory, I'm only looking at probably one third utilization of the memory. If I'm looking at the disk, it's not much activity at all. Ethernet, yeah. Oh, well, I guess it's Wi-Fi, so there's Ethernet, no wonder. The GPU, not much happening. Okay, so, but this is what you find with physical computers. With physical computers, people go out and buy the most resources they can afford. Okay, I can bet every one of you guys, you went out and you had a certain amount of money and you spent right up to the limit of it to get the best CPU, the best graphics, the best hard drive, the fastest whatever you could. And I bet you every one of you guys probably wouldn't be 100% utilizing every resource right now. Okay, and that's the problem with physical computers. Most of the time, they're only using a fraction of what they're capable of. So what virtualization tries to do is actually, instead of wasting those resources because you've got so much capacity on your physical machine, it's actually going to put more virtual machines, turn more virtual machines on, and utilize those free resources. So we're actually able to more efficiently and cost effectively use those resources. All right, what is virtualization? There's type 1 and type 2. I think if most of you guys would have done for IBM. Type 1 is this, sorry, let's go with type 2 first. Type 2 is what we, type 2 is what we used to, okay? Type 2 is what we used to. Right in front of us on all of our computers, I'm guessing we have a physical hardware. We have a host operating system, okay? For Matthew, that's Mac. For the rest of us, it's probably Microsoft, or from some special students, maybe Linux. But on all of that, we've got a host operating system. Then we've got a hypervisor installed, whether that's the Microsoft, probably for you guys, it's probably going to be VMware Workstation. And then we have virtual machines, which is running on top of that. So this is what's called a type 2 hypervisor or hosted virtualization software. Okay, but that's what we learned. That's what we usually refer to desktop virtualization. But what we're talking about in this subject is server virtualization or enterprise virtualization. And that's usually typically a type 1 hypervisor. What does that mean? You notice there's a level that's actually missing here. There's a layer that's actually missing here. All right, that's the host operating system layer. Because if these are the workhorse computers that sit in the server room and just virtualize your virtual servers, they don't need a host operating system with all the bells and whistles like we have, okay? So really anything that's in a host operating system that's not necessarily is really a waste. And from a Microsoft perspective, the best hypervisor hosts are the nano servers. If you remember when we talked about nano servers right in 5ICW, and if you remember the size of a nano server's installation just for the operating system without data is about 450 megs, because that's just enough operating system to do the basic operating system functions with the Hyper-V installed on it. and then it can actually utilize all the resources. Instead of wasting for the host, it's going to utilize it in the virtual machines. So examples of that would be vSphere, Citrix, and Microsoft Hyper-V. Someone did a little message. Yeah, that's right, Matthew. So in this subject, we're talking about type 1 hypervisors, okay? So bare metal, sometimes referred to as bare metal, because basically we install the hypervisor onto the physical hardware. All right, what is network virtualization? We'll talk more about this in the future, but we'll talk about how we can actually, we all know that we have virtual networks, just like we had a bit of a discussion about the VMware virtual networks previously. Okay, and obviously, that's the thing. Our virtual networking does not have to reflect our physical networks. Some of our virtual networking is totally isolated from the physical network. Some are connected to the physical network, and we can in fact extend things, capacity or capabilities from the physical network into the virtual network, such as the fact of virtual switches. Okay, so we can have simple virtual switches, but we can have even Cisco virtual switches. You have to download and install a package, but then you'll be able to create a Cisco a virtual switch. So what does that mean? That means you can actually extend things like priorities, quality of service from the physical world into the virtual world. We will also talk about software-defined networking in the future. It's a little bit hard to understand, but if you look at this diagram, you have red and blue virtual machines. And red and blue basically mean that they're two virtual machines which belong to two different companies, and the physical servers you own, so you're a hosting company. So obviously, if they belong to different companies, then their data should not be able to interact with each other. So you have a blue network and a red network, and they need to all interact with the physical network as well. How do you keep them apart? There's various ways. We can do VLANs in virtual networking, and we can also do software-defined networking, which, like I said, I'll explain a lot more detail later. So some key technologies. So we're going to compare a little bit of VMware and Microsoft side by side. So hopefully you guys are all aware of VMware. You should be. We know that we got VMware Workstation, but like Matthew just mentioned, VMware also sells probably market leaders in the enterprise virtualization field. Microsoft is a close second, or catching up, always improving their market share. But VMware, probably the biggest provider of enterprise virtualization. So what is Microsoft's hypervisor? It's the Hyper-V. What is VMware's hypervisor? It's the vSphere hypervisor, which is called ESXi. What is the VM management tool in Microsoft? Is the Center Virtual Machine Manager. In VMware, it's the vCenter. The self-service, you can see that they're very similar. Self-service means that once you create the infrastructure, you can actually delegate controls to your clients, so they can actually create their own virtual machines or manage their own virtual machines. We've got self-service app controller in Microsoft and vCloud Director. We've got monitoring, we've got operations now, and vCenter Ops Management Suite. We've got data protection. We've got protection, which is data protection. We've got DPM, which is Microsoft System Center Tool, Data Protection Manager, and we also have vSphere Data Protection. We have Service Management, which is Service Manager, and in VMware vCloud Automation Center. And automation, there's Microsoft Orchestrator and vCenter Orchestrator. The funny thing, guys, you're going to notice quite a bit. You're going to notice that when we talk about something in Microsoft, there's going to be some comparison to a VMware equivalent. It's no coincidence, guys, because VMware was out there doing this quite a bit way before Microsoft got in the game. And what Microsoft has done is actually almost taking the best parts out of VMware and try to develop similar abilities, similar strategies themselves.
Did you just say they're almost copying it in a way?
Well, I couldn't say that because that'd be libelous. But I could say that, yeah, if it's a good idea, why not use it? Okay. So basically, Microsoft, the whole suite is called the System Center. System Center has many other functions as well, like we spoke about. But in the VMware, it's the vCloud suite and vCenter. If we look at the licensing, okay, I know this is 2012 and the prices might be a little bit off, but we all did the standard with the Microsoft server standard. You get 2 instances for free afterwards. Okay, 2 VMs for free with the 1 license. 2 server VMs for free, should I say? And also data center, you have unlimited, but don't forget these licenses are based on a number of physical CPUs or CPU cores. So Microsoft's not silly; they're going to get their money because they know the more CPU or CPU cores you have, the more work you do, the more virtual machines you can do, you can run. For VMware, there's standard, advanced, and enterprise, and you can see the prices are quite high. So that's one of the challenges with VMware is that you pay for VMware vCloud suite, and they are high. It's very good, no doubt about that. It's very good, but you pay for it. But on the downside, if you actually are using lots and lots of Microsoft virtual machines like server, domain controllers, web servers, and etc., then you need to pay a license for each of the virtual machines. You get what I'm saying, guys? So that's why Microsoft is actually gaining quite a bit of ground on market share because of the fact that, hey, I pay for data center and I get all of the unlimited virtualization. So for smaller companies and schools and education institutions, Microsoft seems like they're winning in that area because of that. But when we talk about large enterprises, large enterprises, they're not scared of this money because what they'll get is they'll just get what do you call it, site license or bulk license or volume licensing, which means they're not scared of paying for additional server licenses because they'll just use the volume licensing scheme, which means they pay for that and they get as many as they need. So that's why you'll see that VMware is probably the main thing data centers use, especially a lot of those data centers that host services, whereas Microsoft is what a lot of governments, schools, and smaller businesses use. Gaining market share in that area, but VMware is still the leader in the enterprise virtualization for a bit larger companies. All right, so we're sort of talking a lot of things about a lot of technologies here, and that's because it's giving you sort of a big picture overview. And we're not really talking details about anything really today. We're giving you a big picture overview, and then as we go along in the topics, we'll be looking at specific stuff and examining that. So basically, when we're talking about virtualization, we're not talking about one server. I know we're talking about Hyper-V, but that's just the part that does the virtualization. There's many other parts of it. So we have the VMM, which is the virtual machine manager, app controller to manage the virtual environment. We manage the physical and virtual components with VMM. We delegate administration. So if you don't understand what that means, it means we give other people permissions, okay, to use virtual machines to do certain things with virtual machines or even elements of the virtual machine. And that's done through, and self-service is done through the app controller. And we have the data protection manager. Automation, we use Orchestra and Service Manager. Monitoring, we use the Operation Manager. And business continuity, we have the DPM or Data Protection Manager. So VMM, like I said, compares well similarly with the VMware vCenter. So VMware is the management server. Okay, so it does not do any virtualization. The virtual machine does not run on it. Hyper-Vs are the, if you like, the workhorses of it, and this is like the management service. VMware features the bare metal deployment of hosts. So what does that mean? That means we can put a new host on by deploying a image. If it's a image to the host, for example, if it's a nano server, we can just deploy that image. If it's a full Windows instance, we can use the Windows deployment services, similar to what we did for those guys who did the SCCM and deploy the operating system to the host. We can use it to create hosts and clusters. We can create what's called host groups, as the name suggests, groups of hosts for management. If we, instead of managing individual hosts, we manage groups of hosts. You're probably wondering, why do we need groups of hosts? Because when we're talking about VMM, we're not talking about the small implementations now with even 20 hosts. We're talking about large implementation, large data centers where we could possibly have hundreds of hosts. Okay, some are even bigger than that. There's cross-platform management. There's storage configuration and network configuration, so we can use that. There's intelligent placement and dynamic optimization, and we'll talk more about this in the future. But intelligent placement is when you create a new virtual machine, what host do you put it on? If you got, let's say, 100, which one do I put it on? With intelligent placement, we'll assess all the hosts that's available, and their capabilities and their suitabilities, as in how much utilization are they getting, and either recommends which host you should use or just does it for you. Just places it on the most appropriate host for you. There's dynamic optimization, and we'll talk about this in the future, is what if a particular physical machine, which is the host, gets really busy. If one particular virtual machine on that particular host gets really busy, it's just going to mean that every other virtual machine that's on there is going to suffer as well. And also, if you had 10 hosts, it doesn't make sense to have one really busy host and 9 really not busy hosts. So 1 hard worker and 9 slackers. So it doesn't make sense to do that. So what dynamic optimization does is it assesses all of the hosts that's being managed, and dynamic optimization will move virtual machines from the busy host to the not so busy host automatically without downtime, okay, by using the live migration feature, which we'll talk about more. Power optimization is similar to dynamic optimization, except that if we're, for example, TAFE closes at about 9:30 every night, obviously utilization is not going to be that high anymore between 9 and 6 a.m. So instead of actually leaving all hosts up and running and doing their thing, and therefore using power and all that kind of stuff, why couldn't we just move the virtual machines, instead of on 10 hosts, back to maybe 5 hosts? Because they're not being utilized that much. And why couldn't we just turn off another 5, which means saves power? Obviously 6 a.m. in the morning, turn back on, move the virtual machines back, and then it's ready for a new day. So this is some of the stuff we're going to look at in the future. So there's also the PRO and the P2V. So that's physical to virtual conversion of existing servers, maybe physical servers to virtual machines. App Controller overview. That's a browser-based console for providing delegated access to manage private and public cloud services and virtual machines. So delegated access, meaning if I am the virtualization administrator and there's a web developer, webmaster, whatever, I don't want to give them full access to become a virtualization administrator, which means they can mess with everything. But maybe I'll delegate them the powers to be able to control the web server virtual machines. Okay, I'm not going to give him all the powers, as in he can just add 1 million gigs of RAM or something like that. I might just give him enough powers so that he can actually change the network it's belongs to in the virtual network. It might restart it. It might be able to take snapshots or restore snapshots. That kind of delegation. So it means limited, constrained powers to these people, so I don't have to do it. Don't forget, if I can delegate someone with permissions to do something, that means they don't have to bug me to go do it. Okay, guys. So basically, it makes it more convenient for the user, or in this case, that webmaster. App controller can connect to multiple VMM instances, and it can connect to multiple Microsoft Azure subscriptions, and it connects to service provider foundation. So basically, the theme of this subject is we have on-premises virtualization, which is what we call a private cloud. But then if your private cloud gets too big, or you want to have external access, public-facing resources, then we can actually move our private cloud assets to the public cloud. And obviously, there's interactions between the public and private, a bit like how TAFE is. So you know that we've got on our site, we've got our local file servers, Active Directory, etc. But you also can access services which is public facing, like the web server, the Learn, the Office 365, your OneDrive, and all that. So therefore, there's parts of it which is in the private and parts of it which is in the public cloud. Evaluating the current environment for virtualization. So this is really talking about migrating an existing traditional servers or network to one that's highly virtualized. So when evaluating server virtualization, consider the following. The project scope, so what's included in the project, what's not included in the project. There's no point giving the client something that they never even asked for, while if you're not going to deliver what they actually do want. What are the hardware requirements? Are there any compatibility issues? What's the application and services? What's the supportability, meaning who's going to support it, and how easily is it supportable? Thanks, Ayrton. Thanks for coming to the class. Licensing. Obviously, we spoke about licensing before, and availability requirements. When we're talking about availability, we're talking about how often it is online rather than offline. Is it an enterprise critical service, or is it just something that's good, but the availability is not as high as some other servers? Don't forget, not all servers or virtual machines or anything are created equal. Okay, when we're talking about technology, it's not egalitarian. There's things which are high priority and things which are low priority. I'd rather sacrifice the performance and availability of something that's low priority, and to ensure that my highly valued assets are running and available. So there's this tool called Map Assessment and Planning Toolkit. Okay, so it's a third-party tool that imports maps outputs. So we can use third-party tools to get the outputs of this map tool, and allows us to do infrastructure planning and design guides. So here's an example. So basically, this map will use your network connection to discover what's on the network, to take an inventory of what's there. Obviously, you need the domain powers. The hardware configuration of servers and infrastructure, shared storage and network. And then this virtual server consolidation wizard will work on this and give you a, in this case, if you look at this sort of display, it's actually discovered your assets on your network, and then it's giving you a graph of how many assets do we have, about 45, and all of these are ready to migrate from physical servers to virtual servers. These are ready to migrate if you make the recommended changes, which means it's got recommended changes. What you need to do to these virtual machines, it could be that you update them to the latest patch. It could be that you uninstall this role or this feature, or you can't have these virtual machines with both these roles on the same virtual machine, and then a list of 15 in this case that cannot be migrated. So what does that mean? It means those were ready to migrate we can just use that P2V, physical to virtual conversion, and just convert them from a physical server to a virtual server. These ones can be done after you do what it says, and these ones can't be done. What does that mean? It means maybe we just have to install a new virtual machine and migrate the data rather than try to convert the physical machines to virtual machines. The map tool will also scan your vSphere host. So vSphere, if you remember, is VMware, and the vSphere hosts are the ESXi, and then their VMs to produce a spreadsheet and report on the conversion candidates. And that's what we're displaying here. All right, so like we talked about, this subject is always going to talk about the cloud, as in Azure, Microsoft's cloud. And basically, it's we're talking about Hyper-V here, but there's always that with the greater vision, and you can see why Microsoft's pushing it, because obviously it's the cloud is a subscription. If you like to think of it, your private cloud is like you buy the assets, okay, and you're responsible for everything about it. Whether you utilize the assets 1% or 100%, you own it, so you pay for it. You pay full fee. Whereas the cloud is more like, instead of buying the assets, I'll rent the assets. So if I need a certain amount of resources, then I pay for that certain amount of resources. And if my requirements increase, then I just pay more. If my, a bit like pay as you go, prepaid plan type thing. If I need less, the best thing is if I need less because of sudden switch, because people have changed the way they do their work, then I pay less. Okay, Azure has the free types of cloud services, PaaS. Let's start with SaaS, actually. SaaS, software as a service. Okay, if you want an example, think of Office 365. All right, so we all know that we can just go to a browser, open up our Office 365, and just use Office programs in the browser. And where is it actually installed? It's installed in the cloud somewhere, and it's actually doing the work in the cloud. All the processing, all the storage, all the memory is actually in the cloud. That's software as a service. There's PaaS, which is platform as a service. So if I was a web server, if I was a webmaster and I needed a web server with SQL backend, with this .NET frameworks, with this Java scripting feature and so forth, I just go to Azure and order up a platform with all that. Then I place my web server there, and then it's going to work. The good thing about software as a service and platform as a service, I don't have to worry about the underlying operating system. I don't have to worry about the patching or the securing of the underlying systems. I just use it. Someone else, I've outsourced that headache to someone else. They're going to worry about patching the underlying systems, securing the underlying systems, and so forth. All I have to worry about is what I put on the system. Okay, so with PaaS, I'm putting my website on the system. As long as that website is coded securely and all that, then I'm good. Yeah, and we don't have to worry about anything physical. We don't have to worry about the RAID. We don't have to worry about the power supply or the cabling or anything like that. And all backups even. Okay, so we can, obviously there's when we pay for a platform or pay for a software as a service, we can choose what level of service we get, like I said, and we pay for it. If we don't want this, we just don't pay for it. It's a bit like going to a restaurant. Okay, I want a bit of this as a side dish, plus that as a main, plus a couple of other mains because I'm a bit hungry, and plus that as a dessert. So I pay for what I actually order. But at the end of the day, I can't complain I'm not getting a Bombalaska if I never ordered a Bombalaska. Okay, for those of you who don't know what that is, that's a type of dessert. So it's more like that. So then there's the IaaS, or which is infrastructure as a service. This is where we can put full virtual machines and virtual networking in the cloud. Okay, the cheapest one is the SaaS, then PaaS, and the most expensive is the IaaS. And this means, you know what, you don't have to worry about the underlying hardware or systems, but you do have to worry about your virtual machine, OS, virtual networking, and patching and securing of. So it makes you think, doesn't it? Why would I even want the IaaS when most of the time I could probably get away with platform as a service? All right, let's keep on going. So Windows, Microsoft Azure, it's called Windows Azure in the early days. They offer compute. Compute is basically, as the name suggests, computing resources, websites, virtual machines, mobile and cloud services, data services, which is basically similar to the OneDrive, where we can actually put data into the cloud. So data management, HD Insights, which actually analyzes your data with business analytics. We can use the Azure Data Services for purely backup. We can integrate that DPM, Data Protection Manager, that protects your data of your whole network and stores in the clouds as your offsite storage. There's app services, which is media services, messaging, BizTalk services, identity, and caching. Okay, so one example of that would be your AD Active Directory, where you can actually integrate it into lots of other apps and programs. Okay, think your Active Directory that you use to log into the Learn, that you log into your Office 365, and we possibly create an app. We develop our app ourselves that requires authentication, and then we plug into the Active Directory in the cloud as well. Networks, there's virtual networking and traffic management. So virtual machines in Azure can be built from scratch. They can be deployed from templates, their templates. So Azure gives you templates like how we create the Golden Master. They've got templates or Golden Masters, if you like, for Windows servers, Ubuntu, CentOS, and a whole heap of other things. They have some of these templates include pre-installed applications like SQL, SharePoint, whatever. Basically, it's because it's being built there and it's built to their standard. It saves you a lot of work. So you don't have to go and build everything, update everything, install and configure all these things. You just order up a template which is a Windows server with a SQL database on it. Clone from that template. Bang, you've got a new VM that has it. You can customize and build from your own templates as well. So you can create your own templates if you wanted to. So you can take one of their templates and customize it, and then you can create your own customized template. You can also upload your VHDs, which are your Hyper-V virtual hard disks, and then import it into a virtual machine in the cloud, and basically they're your customized VMs. Extending your data center. So obviously these days, more so than ever, your data center, your on-site premises is getting probably less and less, whereas your cloud offerings are getting more and more. So you can extend your private cloud into the public cloud by utilizing Azure. Okay, so like I said, next subject you would do after this one would be the 5 PTS, which we'll talk about, take you into that Azure. All right, guys, so that's the end of the presentation. And what I'm going to do is I'm going to stop recording.